el cielo de ternura, en un lugar que me vio jugar de niño. Tuve amistad, las memorias de una infancia feliz, como la lluvia, hoy regresan junto a mí. En un lugar quema el cielo, las estrellas. En un lugar todo el verde está de fiesta. Vamos a andar, a sembrar, a cosechar con amor para la gente, para la...
Listo, Carlos, puedes comenzar.
Gracias, Alejandro. Good morning, everyone. After such a lovely video about our campaign, Growers for the Future, and so on, today we continue with our external webinars when we have a special guest. And today we have our scientist, Dr. Ulrike Levender, who will present or who will talk about soil health, the global picture, what is happening, and so on. So as a short introduction, Dr. Ulrike is working as a scientist in Yara since already 11 years. She's a biologist by training, and she has a PhD. Basically, her PhD thesis was about nitrogen oxide emissions from fertilizers. That was a joint collaboration between the university and Yara. As I said, since already working for Yara 11 years, working in different topics. And since 2019, she is the scientific expert in the area of soil health. So thank you all for being here. Thank you for joining us in such a great initiative, sharing knowledge and having external, or let's say internal guests, people that are working with these important topics. She is now based in Germany. So without any more introductions, Ulrike, the floor is yours. Thank you again for being here with us, and we are very pleased and glad to see you sharing with us this knowledge. Thank you.
Yeah, thank you very much, Carlos, for the nice introduction of myself. So as Carlos mentioned, I'm now responsible within Yara for everything related to soil health. So from a sustainability aspect, everything which is fertilizer related and soil health related is on my desk. And I'm going to show you a bit about soil health, a global picture, as soil is seen on a global scale. For connectivity reasons, I will stop my camera, and during the Q&A, I can open it again. I hope you don't mind. So, first of all, the webinar today is divided in three elements. So as I mentioned, I will talk about the worldwide scenario of soil health. I will start with a global picture and general definitions then, and later on I will go a bit more into detail what kind of indicators are available and can be measured and their challenges with it. So let's see. Okay, now it's working. So soils have received comparatively little attention in the international climate policy. So This disregard does not reflect their relevance as a source of emissions and the necessity to take actions to adapt to climate change to ensure food security. So an estimated 1/3, I hope you can see my pointer. So an estimated 1/3 of the agricultural soils are severely degraded. So which leads to agricultural productivity losses, reduced water holding capacity here, and the ability of the soil to capture carbon. And this deterioration of soils is a risk for food production and subsequently a threat to food security in here. So, as mentioned, 1/3 of the soils are already degraded, and I will go a bit more in there on the next slide. So, I already have it as a header because it is very important. Soil degradation occurs due to a variety of both natural and human-induced processes. So this triggered different initiatives. Here I've listed some like the Global Soil Partnership and others to protect the soil. And the most significant threats to soil functions at a global scale include soil erosion, loss of soil organic carbon, soil nutrient mining, soil nutrient imbalance, acidification, salinization, and sodification. And on the following slides, I will go a bit more into detail. So there was done a global assessment of the 4 main threats of soil by the FAO. So you see, I've tried to classify them according to the 4 main threats. So the first one is erosion. And I marked here, of course, a field of interest for you. So we see the first threat is erosion, followed by the second main threat, which is the loss of organic carbon, so the organic carbon change. And the third main threat is below in bluish, you see it here, it's salinization and sodification. Followed by the last and the fourth main threat is the nutrient imbalance. So meaning either excess of nutrients or that the nutrients are not available in the right order and for good and sustainable crop management and soil management, of course. And looking into that, you see that these are also the 4 global main threats, but they are also belonging to Latin America. So it fits, very tremendously also to Latin America. And I've also listed the other threats to be consistent. They are of minor global interest, but they are still in some areas still of huge importance, like the loss of biodiversity, contamination of soils, acidification in yellow, and sealing of the soil, meaning building of streets, houses, and so on. You can see that this is very tremendous, and it's a main threat which is for responsible or the threat within Europe, as an example. Looking a bit more into detail, what does that mean if we look into Latin American region? Is then I tried to show it a bit differently. So in order to give information on soil, land use, and ecosystem services affected by soil threats, Latin America can be split into biomes. So biomes meaning these are environmental zones with similar climatic, faunal, and floral combinations. So meaning similar climate, flora and fauna is also similar. And Latin America can be classified into 11 biomes. And the boundaries of these biomes, they correlate with the major soil landscapes. Meaning that if we translate that to the farming systems, they fit quite nicely to the main farming systems also. And this I'm going to show you in the following slides. If we look to the main farming systems, I tried to take this map. And you see the irrigated areas, they are numbers in 1, and the grayish areas also here at the coastal borders. And up here, and you see also the greenish ones. These are the tropical and subtropical moist broadleaf orders and broadleaf forests, which are here more in that region, followed by all the others. And if we look there and try to look a bit more into the soils, what does that mean? How are the soils within these farming systems? I picked several parameters which can be used to determine soil and also soil health. And one of it is the soil organic carbon. As you know, soil organic carbon is also high on the agenda, thinking of carbon sequestration also, which is part of soil health, but it's, as I mentioned, it's only a part of it. And on the right-hand side, you see the soil organic carbon map. So it's the topsoil carbon. They have displayed there. So it's topsoil, meaning the first 30 centimeters. And you see the different colorings, and the lighter the colors, this brownish color, the lower the soil organic carbon is. And of course, the darker, the browner the color, the higher the carbon content. And you see that if we are looking here into the Cerrado regions here around, and you see here that we have already quite light carbon contents in there, and also within here where we have forests and we have also deforestation there. So these are already in a quite low organic carbon stage. So if we're looking to the carbon stage itself, it is somewhere in a normal range, is somewhere between here, of course, depending on the agricultural use and on the purpose of that soil. Yes, and if we're then continuing with another possible measure of soil health, then I'm going to show you the soil pH. And here you see the soil pH also, again, from the above soil layer. And you see here the reddish area here is the most acid area. And this is the area which have experienced and still experiences deforestation and intensive agriculture. Also, if we look to the orange one, it is also still where we have high agricultural use and high agricultural inputs, where we have low soil pH. And the more extensive use and the more pristine state, the higher the soil pH is. So also we can link that if we're looking here again on the left-hand side, on the bluish part, on the Cerrado region, and it's a very productive and a very, very intensive area, and you see we have quite low soil pH around there. Of course, all these maps have to be taken with caution because they are depending on point measurements, and between each points they are extrapolating that. So meaning that, of course, they integrate point to point, and in between, of course, there can be also a mismatch on a very local and tiny spot within a certain field look differently. And if we are then looking to another very important parameter, if we think of crop production, then nutrient availability is also a very important factor to look in. And also here on the right-hand side, you see a map of the nutrient availability in the soil. Also, again, the upper layer is there in focus. And you see also the different colors depending on the different constraints. So green is no constraint, so there is almost no problem. Everything is in a quite nicely state and moderate state. And then you have the yellowish ones, which are already a bit not nice. Nice situation, and the brownish colors are already having problems. Some have very severe problems, and some have lighter severe problems. But again, if we're looking to the Cerrado region, we see also there we have already very severe restrictions on the availability of nutrients. So, but the severe and very severe constraints in nutrient availability does not mean that there are no nutrients there. They might be due to the oversupply of nutrients and also the nutrient imbalance. So this is meant with this nutrient availability. Because in some regions, and you have some soils which are highly fixing phosphorus, for example, and you might have trouble to acquire that phosphorus for your plant production, and even the soil it is hard to achieve a certain phosphorus level. Looking a bit into a very projective map is the trend in soil improvement on the right-hand side. You see here different colors again, depending on their trends. So the reddish one is the negative trend made mainly by humans. Then we have the negative trends mainly by the climate. And we have the more positive trend by humans, followed by the positive trend by the very positive trend, sorry. In between, you see these lighter colors. There is no significant change. I have to already tell you, so this map has to be taken with caution, because this map is an indirect measure of kind of soil improvement trend. This trend is measured via trends in NDVI from 1981 up to 2006. And this is translated into greenest losses and gains distinguished by climate and human causes. So there are several assumptions made, and the difficulty here is with this method is to isolate climatic influences from human influences and the variable link between the greenest trend and soil degradation. But nevertheless, you see already there, if you remember the previous maps I've shown you about carbon, soil pH, and the nutrient imbalance, you see also here some reddish spots also around the Cerrado region, which fit to the previous maps quite nicely. Yes. Now this is a bit more to show you how does that look in Latin America. And as I mentioned, it's only very few parameters I've picked. This is due to the fact that some maps, they are not easy to show because the background data behind is not that frequently available, and therefore I decided to take the very important ones. Nevertheless, I mentioned before, I wanted to show you the global trend and the global situation about soil health. And what I've done is I've done a global trend research, which is shown here. So it's a Google trend search starting from 2004 up to today. And what you see here is the popularity of soil health in public, meaning this trend analysis was done with the keyword soil health on a global scale. Nevertheless, you see that the in 2004 it was already quite known in public that soil health, formerly called soil fertility, soil quality, was already quite known in public, and then it decreased slightly for also other reasons, because we had this climate change, and there the focus was more on gaseous emissions and other things. So the focus was a bit decreasing, but since 2015, with the International Year of Soil, which started in 2015, and this was aired by the United Nations in December 2013, after the introduction also of the World Soil Day. So meaning with this declaration of National Year of Soil, also the audience, the public, got a bit more interested in soil health. And each year on the 5th of December, there is a celebration of the World Soil Day to keep attention on the importance of soil. And how is that if we're looking for different stakeholders? So here you see soil health drivers. So several press releases are illustrating that soil health has become an important topic, including different stakeholders taking actions, for example, like the World Business Council here, for sustainable development. So in all the others, they are only examples from press releases to show you the importance of soil, and soil health is further increasing and increasing. You see here, for example, the European Commission, Soil Matters for Our Future. So there are also very, very dramatic headers sometimes used to make the public aware of the issue and to take actions further. So as you see, it is quite important in public and also for several stakeholders and initiatives. And if we're looking into the global sustainability goals, then I'm showing you that here. So we have soil health is key for delivering several of these sustainable development goals. And they are the blueprint to achieve a better and more sustainable future for all, as they address the global challenge we face. And I've marked only a few of them. So, for example, it's the zero hunger. So this is via the sustainable intensification of agriculture, for example. Therefore, soil is very important to keep in mind, to have it in a sustainable manner. Also, if we're looking to the sustainability goal number 3, so which is the good health and well-being. So there it is the suppression of pathogens and contaminants and closing the nutrients. And if we're looking to the number 6, so which is the clean water part, and there also it is increasing the blue and green water resources, and there also soil has a very important function because it's filtering the water. And also number 13, I will go ahead, 15, and finally also number 1, because everything later on relates to zero poverty. If the soil is not in a good shape, farmer cannot sustainably produce his food, and therefore he will facing poverty at the end. And also, if we cannot secure our food production, we will increase poverty. Yes, therefore, if we're looking into that and link that to the sustainability goal, it is very important to focus also on soil. And this also several food companies have found more in there. I hope you can see that, because sometimes I have on my screen some loss of my presentation. I hope you see it. But big food brands have started investing in their ingredients. So by helping farmers improve soil health and sustainability, and also not only helping the farmers, but also investing into research and investing into awareness of soil. Because they also recognized if we don't look into our soil and if we don't have that in a good shape, we cannot produce the food, and they cannot produce their ingredients for their further food processing. Therefore, the interest for the food companies or within the food companies is very high also. And as I mentioned, these are only a few examples. There are much more outside. And I will not go into detail of all of them. I have only picked some headers to show you also the scene according to the food companies. And also Bill Gates is an example that he also said we should discuss soil as much as we talk about coal. He meant it in that context, looking into greenhouse gas emissions, but also if we think of soil, of course you have greenhouse emissions, but you also have the delivery of food. And a further text of this, he also stated that we have to focus on soil. And they have more and more attention also within their foundation, so the Bill and Melinda Gates Foundation, and they are focusing more and more on soil. And they have several initiatives, several projects running, and also we within Yara, we are discussing with the foundation, trying to setting up projects, research, where soil health is of interest. And to try to make our customers a bit more aware of soil and the importance of soil, we introduce always on the 5th of December, as I mentioned, the World Soil Day. We have here we are showing on our homepage some facts and statements about soil. So for example, here, Frank D. Roosevelt said very few years ago, the nation that destroys its soil destroys itself. So of course it's a very provocative sentence, but I think it fits quite nicely, because if we don't care about our soil, we will get in trouble, of course. And then of course some very theoretical facts, how an ideal soil should look like. And also a bit to illustrate a bit more the importance on soil, looking into the microorganisms, because a soil is a huge habitat for soil microorganisms. So, and this is what we try to illustrate, that a healthy arable soil contains 5 tons per hectare of soil microorganisms. But yeah, who to count 5 tons. So 5 tons is a bit not touchable. And that's why we said, okay, you can compare it with 100 sheep per hectare. So it's quite huge. And also if we're looking into the structure of a soil. So if you have a good structure, you have healthy deep roots, you can achieve high nutrient use efficiency, and you can reduce the environmental impact of the applied nutrients. So if your soil is healthy, of course, you can diminish also the environmental impact. So previously I've mentioned several functions of a soil, and I will go a bit more into detail of that. So soil performs multiple key functions linked to agricultural productivity and environmental resilience. So, and here are a few of them. I will not go into detail of them. I only wanted to show you that there are quite a lot of soil functions. And they are delivering then the ecosystem services. And of course, they are important. And in the following slide, I've picked only a few of them. And these are mainly these are the main soil-mediated ecosystem services derived from agricultural soils. So in here you see, for example, up here, you see the water supply and water quality. We also have, of course, the production, which is very important for the farmers. We also have the biodiversity conservation, as mentioned, a habitat for microorganisms, but not only for them, also for small animals and advertebrates, and also and all others, fungi, for example. Then, of course, we have pests and diseases. The soil can also function like a system where you can have natural, let's say, antibiotics. Therefore, it is important to have it in a good shape. And also, if we look in here, we have the carbon storage and therefore also the climate regulation. So it has a huge impact on it. And finally, also the erosion control. So if we secure a good rotational agricultural management, we don't leave it bare, for example, in several regions where we have a lot of wind erosion, then of course we can try to overcome several threats and we can ensure these functions of a soil. So now I've told you already a lot of things, but what does soil health mean really? And how is soil health defined? So when we can limit it to quite, I would say, nicely sentence. So soil health is in principle the capacity of a soil to function. So meaning it depends on their functionality of a soil. So you can have a forest soil. A forest soil has different functions than, of course, a pure agricultural soil. And also if you think of prairie soils, they have also different function. And within these functions, if the soil is working nicely and it's functioning good, then it is a healthy soil, or it is at least considered as a healthy soil. And now the issue is determining soil health is not that easy because it can't be measured directly. But we can indirectly measure the functions that make up soil health by measuring the indicators. And indicators, they can be either grouped from the physical. We have physical indicators, we have chemical indicators, and we have biological indicators. And all of them, or within these indicator groups, there are some, let's say, specific indicators. I will go into detail a bit more in the following slides. So here you see, I called it the three pillars of soil health. Again, we have the chemical parameters or indicators, we have the physical parameters in bluish, and we have the biological parameters. And below, I've only listed a few of possible parameters within each of the groups. And it is very important that any protocols thinking of a soil health assessment, so trying to classify the soil according to its health, that the integration of chemical, physical, and biological measurements, they have to be combined, so they have to be integrated. But also, if you're searching for several parameters, then it's also important that they have to be sensitive to changes in the management practices. They have to be consistent, reproducible, and of course also easy to use and integrate, and to be cost effective at the end. And that's why I've only listed here a few, because they only shall give you an example. I will now go a bit more into these parameters. Don't be afraid about all the very tiny parameters listed, but I only wanted to show you that there are a lot of parameters which can be measured to determine soil health. And I tried to classify it again. You see up there in the graph, you see the greenish one is a biological. You see, this is a example from a study, and this study they have screened several publications and assessments, or including assessments, and what they tried to find out what kind of parameters are used and how often they are used within the research and in the assessments. And the longer the bar, for example, if we take here the total organic carbon, the longer the bar, the more oftenly used is this parameter within an assessment or in a research publication. So, and you see already there are quite a lot of, so the available phosphorus, for example, we have the soil pH and total soil organic carbon. They are quite frequently used within assessments and research, due to the fact that they are compared to other parameters quite easy to measure, reproducible, and also from a cost point of view quite costless. But of course, you also have them for the physical part, like for example the bulk density, which is also quite frequently measured. But if we're looking to the biological part, it is underrepresented compared to the others, due to the fact that methods are evolving, and there are, of course, quite a lot of new methods already there, like DNA analysis, and so on and so forth. So genomic analysis to see to look into metagenomics, but they are quite expensive, time-consuming, and the interpretation is not that easy for these results at the end, because a genomic analysis does tell you only something about the occurrence of these microorganisms, but at the end it does not tell you necessarily which ones are active and which ones are active at a certain state. Therefore, they have to be combined with others. And therefore, also in the upper part, in the biological part, you see these are more generic biological parameters, like earthworm counts. They are quite easy to do, but of course they are laborious. But compared to genomic analysis, they are quite easy. Also the N mineralization then, it's quite easy to do. Microbial biomass, it is differently also done. And also soil respiration, it gives you a kind of hint how active your soil might be. Therefore, there are not that much biological parameters listed, as some of them are quite time consuming and expensive. Now you might be overwhelmed about all what kind of parameters can be used and how to do that, and whom to search for. Another thing is we need to keep in mind is that we need to differentiate between given and manageable quality parameters. So meaning that if you have properties, for example, you have given properties, you cannot change. You have a certain soil and he has his characteristics. So for example, you have a sandy soil, for example, and you have a loamy soil, and you try to compare them. You cannot change them, because a sandy soil will ever be a sandy soil, and you cannot reach the level of a loamy soil, and vice versa. So therefore you have, and everybody has to be aware that some soil properties, they are given and they cannot be changed, and we have to live with it. And some, of course, they are manageable and we can change them. And they, of course, they can also change due to the management we are using. For example, like bulk density. Depending on the kind of soil tillage system you're using, and the frequency of driving through your field is, of course, changing your bulk density. And either it is changing it, or either you keep it quite constantly and you are sustaining, or either you are increasing, so you are improving, for example, your soil bulk density or another parameter, or you decrease that, so the soil gets worse. I think it is very important to keep that in mind, that we have manageable parameters and we have non-manageable ones. Nevertheless, farmers can build and restore healthy soils. So the indicators, they can be measured in the laboratory or in the field. And this is here as an example. So it's a bit more schematically shown here. But you see, of course, if you are not managing well, you are degrading your soil. And depending on the degradation stage, it is quite hard to restore your soil at the end. I will not go into detail of it, but at least you see that we have, of course, a soil which contains organic matter, and it's high in microbial activity. Good soil structure and nutrient cycling is also quite well. And then if you degrade further, you can have compaction and capping, pure water infiltration due to the compaction. Soil aggregates break down. You might have cracks there. And further down, if you don't change something in your management and you recognize it not quite early, you are decreasing your soil health and you are degrading the soil. And of course, if you are already at a very degraded part, it is very hard and laborious and expensive to restore the soil again. And on the right-hand side, I've listed again some parameters with the similar groups as mentioned before, chemical, physical, and biological parameters, which can be either measured in the field here or also in the lab. There are already several assessment approaches out in the field. So don't be afraid you have to do everything by your own. No, there are some assessments already out. you can contact the companies or the institutions, and they ask you for soil samples. And of course, they have different different methods they are using. So I've listed only a few of them. Of course, the list is much longer, but only a very few of them to show you there are assessments and soil health initiatives out there measuring soil health. But as I mentioned, there are different methods and they are, for the time being, not harmonized. So meaning it's really, really important that you select the correct assessment for your purpose. Because depending on their intention, specific methods are selected. And of course, you can then have an issue that you are selecting parameters which does not tell you something about your status because they do not fit for your purpose. And this should be known beforehand. And this is also the challenge of a comprehensive soil health assessment. And I've listed here also because we have a lack of agreement about what soil health is and exactly needs. So I mentioned before, soil has to function. But what does that mean? So as mentioned, it is hard to compare a pure arable soil with a forest soil. This comparison will be unfair because their functions are different and their purpose is different. Therefore, as mentioned, there are diverse methods and approaches, and later on there need to be a kind of standardization, at least to get a bit more familiar and also a bit more the idea what kind of assessments can be used for which kind of purpose. So in the following slide, I've listed a few potential stakeholders if we think of soil health. And there are, of course, as mentioned before, we have the food companies, and they have their pains and drivers, like the security of the supply. And of course, they have to protect their brand values, and they have to meet the sustainability targets. And therefore, of course, they have different reasons for that. On the other hand, we have also the farmers. They need to assure the productivity because you have more and more climate change and you need to have it climate resilient. And of course, if you think of compliant issues, so they have, of course, to be compliant at the end. And we have, on the other hand, we have also the governmental institutions or governments and initiatives. And here also, they have different pains or drivers they are looking on if they talk about soil health. Nevertheless, if we sum up what I've told you, so this can be kind of summary, then there is a global challenge, but this connects to our vision, so to Yara's vision. So as mentioned, we have 1/3 of the global soils are already degraded. And I've shown you soil health is high on the agenda. And agricultural practices relevant for soil health can be used, like special soil tillage, thinking of how to apply the nutrients, how much nutrients if we think of nutrient imbalance issues. All these things. So, of course, we have healthy soils. They are important for the agriculture, the vegetation, biodiversity, for pollution control and water quality. And the pace of degradation is really alarming, as I've shown you in the maps before. Erosion, salinization, and all these things. I will not go into detail of that, but at the end, the vision of us is to have a collaborative society, a world without hunger, and a planet respected. And if we take all these three together, then we are fitting to our vision. And then I'm already at the end, and thank you for your attention.
Ulrike, thank you so much for such an interesting presentation, really. So as a matter of, let's say, review, we have people connected from Mexico, Colombia, Ecuador, Argentina, Peru, and even some people from the US. So yeah, very good. Many people interested in this topic. If you agree, maybe we can go to the Q&A session. I got some questions here.
Yeah.
Great. Cool. So let me go first with this one from Argentina. Do you see that we have actions to take at farm level that can improve the soil health situation?
Yes, of course. I think it might be a bit kind of oldish view, but nevertheless, if we're looking into crop rotation, for example, proper crop rotation, this already can do a lot about soil health. It can restore soil health quite easily if we think of proper and go back to proper crop rotations. Then, of course, if we think of, there are the 4 R's outside. So, for example, right time, right use, right amount of, for example, the nutrients, but also for, if we think of tillage, all kind of stuff. If we consider these, I think we might not run into trouble regarding soil health. Then our soil should be in a nice status. Of course, you might have natural limitations of a soil. A soil can be naturally lacking nutrients. Therefore, of course, you can apply the nutrients. But agriculture itself, if it's properly done, can be done in a sustainable manner with quite easy, manageable strategies, like, as I mentioned, crop rotation, crop depending and crop demanding application of fertilizers, also herbicides, all kind of management aspects, of course.
Right. Thank you, Ulrike. Thank you. Let me go with another one. Do you think, at this one from Mexico, are there some checklists I can use to evaluate my soil health? There's a checklist that I can maybe go one by one.
Oh yeah, there are a lot of checklists outside. As I mentioned, there are also a lot of assessments outside. It strongly depends on what his intention is. So if he already sees, for example, a lot of cracking in his soil, or he already sees that it's losing, let's say, or the infiltration is not working properly, then of course he has to take different measurements, as he knows, or as, for example, he only recognizes a decrease in his yield. So the first actions he can do is going out in the field, looking into the soil. Does it look nicely? And this can also be done by the fingers already, to see how is the status. And then, of course, there are a lot of lists outside. But this strongly really depends on, does he want to take the measures? Does he want to also, not only the measures or the samples, but also does he want to measure it? And then it's quite tricky. But there are a lot of laboratories also, they can do at least basic analysis, if we think of chemical analysis, like the nutrient status, for example. And this gives a first hint. And from that, if the nutrient status is quite good, then he can further go ahead and checking different other aspects, like, for example, several pests which might be there, or or the water infiltration, aggregation stability, soil respiration, things like that.
Thank you, Enrique. Here, one from my side. We have still some questions over there in the chat box. But I have seen that you mentioned that many food industries are quite interested in this topic.
Yes.
Is there like, let's say, common understanding or new regulations in Europe, in the US, that are forcing them to be kind of aware of this topic? Or is this also part of this environmental awareness that is happening currently, to be aware of the impacts of the agriculture and so on?
Yes, it is more about the environmental impacts. And they are looking into the soil, and then they recognized, of course, they see their farmers, they are struggling in some areas, achieving the quality of the produce. And they see also that not even the quality, also the amount of the produce. And there they recognize that more and more, and there they want to take action on it. But for the time being, only if we're looking into the sustainable development goals, there is some kind of pressure, of course, for also the food industries. But there is not a strict regulation on it.
Okay, the United Nations as well. I have seen that even the United Nations, the European Union, they are even publishing about it, like be aware of the soil is important and so on. So it's not just production, like be aware of the resources and keep them. Yeah, okay. Very good. So I will go here. Another one, good talk, thanks. Regarding biological parameters, it would be good to add to your list the use of eco-physiological ratios, which are more robust indicators of soil health. That's a comment from Gustavo Martos, I guess. So that's I don't know if you want to add something, or it is a really valuable comment.
I got the first sentence. I didn't get the first sentence. So it was eco. And then
eco-physiological ratios.
Okay.
Which are more robust indicators.
Of course, they are, but to have these ratios, of course, you have to take the measures, and then it depends on the assessment. If they determine the ratios and they use the ratios for interpretation. I didn't go through because this is then focused in the assessments. This is not an indicator in itself. It is then it's an integrated indicator, so to say.
Okay, thank you, Rick. And thank you, Gustavo, for your comment. Very, very valuable comment.
Yeah, it's a good comment.
Right. Another one. Could you provide, please, case of studies or examples of restoring soil health in monocultures, such as corn and beans production in the US or Brazil? Thank you. Marco, as well, thank you for your comment and question. You can see maybe the question down there in the
I can
screen?
see the question now,
okay,
yeah.
Cool.
It is not that easy to give already restoration examples for monoculture croppings. As monoculture croppings per se are not the best, of course, agricultural practice. I know that they are, let's say, from a final output point of view, they are important, but from a biological point of view, yeah, they are critical to look for. So it is not that easy. If we would have already such restoration examples, then we would already be a step ahead. So it's not so easy to tell. Absolutely.
Okay,
it really depends also on the climate and on their special situation. It is a very generic question. It's good to have it. But it's really strongly depends on the detailed example.
Okay.
How to solve that issue.
Fine. Another one here. How to make an example of source or soil samples for study the level of microorganisms, and these to serve for soil health. That's the first question. And what protocols or what protocol is the best for it, for microorganisms, and to use them as an indicator? And thank you, Miguel Angel Acosta, for your question.
So if they are taking soil sample, then it depends on what kind of analysis they want to do. But principally, the most active zoning is, of course, it is the upper layer. So it's the plowing layer, or let's say that the first, to make it a bit more, first 30 up to 50 centimeters. So this is the most active zone. And from these, of course, the soil samples have to be taken. And if we think of microorganism determination, then it's critical, because it depends on also your analysis. You can have direct measures, then you have to have fresh soil to make this analysis, or you can even freeze the soil, but then it has to be frozen very fast. Otherwise you break down the microorganisms. They are getting broken and they are at the end not active. But for a general gene analysis, to see a distribution pattern, what kind of microorganisms are potentially in the soil, I would not call it standard soil sample, but yes, a soil sample, and this can be sent to several to different labs. They are capable doing these genomic analysis and distribution patterns, so these meta-analysis, to see what kind of microorganisms and what kind of frequency there are. This can be sent to them and they can analyze that. But nevertheless, this does not mean that they are active in the soil. This is a very generic analysis. It does not tell you about how much of these organisms or what kind of organisms are active. They are present in the soil, but they can also kind of be dormant in the soil. They can sleep in the soil. So it's, it depends on what kind of microbial analysis they are doing. I would always recommend to combine that with a kind of enzymatic analysis to see the enzymes, because the enzymes, they give you a hint about, are they active? Because if the enzyme is available, then it is much more likely that they are active and doing something in your soil.
Right, okay. So enzymatic analysis, and also this is like an overview of the microorganisms that are in the soil, but it doesn't mean that all of them, they are, let's say, working or active, I would say.
Yes.
So we should be careful with that. Okay. Thank you, Ulrike. So I guess that we go, wow, many questions. We have to be careful with the time.
Okay,
I'm really glad to see that people, and it's already, I guess that in Germany, 6 in the afternoon, summertime. Good. Okay, I will try. What are the steps for a country like Colombia to encourage soil care? That's the first one. And thank you, Miguel, again for your question. So there are 2 questions. Let's go with the first. What are the steps for a country like Colombia to encourage soil care, to be aware of that necessity? Or
yeah, this is it's also, to make awareness of how important the soil is. It is it is not that easy, and I'm not so familiar with the Colombian situations, to be honest, but nevertheless there are some indications that also some soils in Colombia are facing several threats. So therefore I would then, starting with the threats, making aware of the threats the soil has, and try to encourage then the farmers or the producers or the bigger companies to focus a bit more on soil.
Right, and if may I add something, Ulrike, this is something that in Yara we are working quite hard, and this is one of our pillars, or one of our, let's say, priorities, to also implement the environmental care and so on. So despite of the fact that we have a very strong portfolio, services, a lot of knowledge as well, we are working and trying to implement and be aware of the importance of the environment, and that's also part of our job. And you are one of the main, let's say, persons working with this topic in Yara. So that's why we are very glad to have you here again. So Ulrike,
Yes.
is there a support from the European Union or the United States to kind of impulse these initiatives, or like around the world, I would say?
Yes, I guess there are. There are some projects running also in Latin America. I'm not quite familiar which countries within Latin America are on their list. So therefore, I'm not sure if Colombia is already on the list, but I know that there are several initiatives like SEAT. They are quite active if it comes to soil and soil health status. And I guess also in US there should be some initiatives. But for the European Union, there are some, and there are some research institutions and some initiatives financed by the European Union to restore soil also in Latin America. Yes, there are some initiatives already running.
Okay.
And I guess, and we are also, at least in one project, we are also involved in there.
Very good to know that. And as you know, and then again, to add something, is that we have scientists, people doing research on it. So this is a priority for us. And then as you and many colleagues over there in Germany and in other countries, trying to do research, trying to find the best way to keep in mind that the soil is important and that we have to take care of our soils, right?
Absolutely.
Okay, so time is running, and many questions for the other people that send us questions. We will contact you back. We will send you the questions, Ulrike, and
Good.
then we will try to reply by email or by chat. So thank you again. Thank you so much for being here with us, for sharing this very interesting information. And you are most than welcome here in Bula. Join us
thank you
in
very
our
much.
webinars and so on. Okay.
Thank you very much giving me the opportunity to talk a bit more about soil, to make a bit more awareness on it, also for others.
Great, okay. So have a great weekend. You are close to the weekend, closer than us. Here is just in Colombia, 11 in the morning. So muchas gracias a todos por estar acá, por acompañarnos. Este es un espacio que hacemos básicamente para aprender todos. Tenemos invitados muy especiales, como Ulrike. En anteriores casos tuvimos otros colegas también desde Alemania. Vamos a seguir con esta iniciativa y les agradecemos por acompañarnos. Siéntanse libres de contactarnos y todas las preguntas que vayan surgiendo. Y bueno, sin más, gracias. Un muy buen fin de semana para todos. Que ojalá se encuentren saludables y que tengan cuidado con toda esta situación. Y hasta la próxima. Que estén bien. Buen fin de semana. Chao, Ulrike.
Ciao. Thank you.